Hey everybody, welcome back for another deep dive. Today we're going behind the scenes to explore something that's pretty much running the show in our digital lives databases.
Right.
And I know it might not sound as exciting as, I don't know, like artificial intelligence or something, but trust me.
It is. It's fascinating.
Yeah, it really is. We've got this presentation titled Database Fundamentals to help guide us. So let's jump right in
Yeah.
and see what makes these digital workhorses tick. I guess the first question is, what are the core building blocks? Like, what are we even talking about when we say database?
Exactly. Yeah.
I mean, we hear the term all the time, but do we
Yeah.
actually know what it means?
Yeah. And it's interesting, I think most people interact with databases every single day,
Oh, yeah?
whether they realize it or not.
Absolutely.
Like every time you shop online or scroll through social media
Right.
or use your bank app, all
Yeah.
of that is powered by databases.
Yeah, it's true. So let's start with the basics. Like this presentation we have opens with this simple question: what is a database?
Mm.
It defines it as an organized collection of information, but
Yeah.
how would you explain that in a way that makes sense to someone who doesn't really deal with databases every day?
Yeah. That's a great question. I think one way to think about it is to imagine like a giant library, but instead of books, it's filled with just tons and tons of data, right? Like millions of pieces of information.
Okay.
And now imagine if there was no catalog system,
Right.
no way to organize or search through all that information.
Yeah, that's a nightmare.
Right. So a database is essentially that catalog system for your data.
Okay. So it brings order to the chaos.
Exactly.
And it allows us to actually find and use the information.
Right.
Got it. Now, speaking of organization, this presentation talks about two main types of databases, relational and NoSQL. What's the big difference between those two?
Yeah, so it really comes down to like how the data is structured.
Yeah.
So with relational databases, everything is super organized. It's like think of a neatly formatted spreadsheet, like with rows and columns,
Yeah.
and all the data has to fit into this very specific structure.
Okay.
Like if you have a database of customers, every customer has to have a name, an address, and a phone number, and all that data is like neatly aligned in these rows and columns. So it's very structured.
So relational databases are for data that fits neatly into these predefined categories.
Exactly. Things like financial transactions, customer records,
Got it.
anything that has a very clear structure.
Yeah. Okay. So then what about NoSQL? Where does that fit in? I mean, the presentation sort of presents it as this other option.
Yeah, so NoSQL databases are a lot more flexible. They're not like bound to that strict, rows and columns structure.
Okay. So what kind of data would you use a NoSQL database for?
So think about things like social media posts, right? Where you have a mix of text, images, videos, maybe, different lengths, different formats.
Yeah, that makes sense.
It wouldn't really fit neatly into a spreadsheet.
No, definitely not. So it's more like kind of a container that can adapt to different types of data.
Exactly.
Got it. And one thing I noticed in the presentation was this mention of SQL, like SQL. It's kind of presented as this language for talking to relational databases, but I'm not really sure I understand, like, why do we need a whole separate language for that?
Yeah, so SQL, which stands for Structured Query Language, it's basically how we communicate with relational databases.
Okay.
So imagine you go to the library, right? And you want to find a specific book,
Yeah.
but you don't know exactly where it is.
Right.
So you talk to the librarian and you tell them like the title, the author, some keywords.
Okay.
SQL is kind of like that language you use to talk to the database and tell it what information you're looking for.
Got it. So it's like a set of instructions for searching and retrieving data.
Exactly.
Okay. And the presentation also mentioned these different types of SQL commands, like DDL and DML. I have to admit, those acronyms kind of threw me off.
Yeah, no, they can be a little confusing. So DDL stands for Data Definition Language, and that's all about like defining the structure of the database.
Okay,
So creating tables, defining the columns, setting the data types.
Okay. So it's like setting up the blueprint for the database.
Exactly.
Got it.
And then DML, or Data Manipulation Language, is all about working with the data that's inside the database.
Okay. So like adding new data, updating existing data.
Exactly. Selecting specific records.
So one is for building the structure.
Yeah.
And the other is for working with the information within that structure.
Precisely. You got it.
Cool. All right. So we've talked about relational databases and SQL. Now, going back to the NoSQL world, the presentation lists a bunch of different types of NoSQL databases. There's key value, document, and graph. Can you maybe give us a quick rundown of what each of those is all about?
Sure. So starting with key value, that's like the simplest type of NoSQL database. It's basically like a dictionary.
Okay.
You have a key, which is like a word, and then a value, which is like the definition. So it's very good for storing simple pieces of information.
Okay, so like storing user preferences, maybe?
Exactly. Or session data, anything where you just need to quickly look up a value based on a key.
Got it. What about document databases?
Document databases are more suited for storing complex data. So think of a document like a JSON object.
Okay.
You can have different fields, you can nest objects within objects. So it's very flexible and good for storing things like blog posts, product catalogs, anything that has a lot of different types of data.
So each document is like its own little container.
Exactly, yeah.
Got it. And finally, graph databases.
Graph databases are all about relationships.
Okay.
So imagine you have a network of people, right?
Okay.
And you want to understand how those people are connected. So you would represent each person as a node and then the connections between them as edges.
Okay.
And this structure is very good for analyzing things like social networks, recommendations, anything where relationships are important.
So it's all about mapping out the connections between different entities.
Exactly, yeah.
Cool.
Mm.
This is starting to make a lot more sense now. So we've covered the two main types of databases, relational and NoSQL, and we've even delved into SQL, the language for relational databases.
Yeah.
But let's go a bit deeper into the structure of relational databases.
Yeah.
The presentation talks about things like tables, schema, primary key, and relationships. Can we break those down a little bit?
Sure, absolutely. So starting with tables.
Yeah.
Think of tables as the containers for your data in a relational database. They're organized into rows and columns, much like you'd see in a spreadsheet.
Okay.
Each row represents a single record, and each column represents a specific attribute.
Okay, so like if you have a table for customers, each row would be a different customer, and the columns would be things like their name, their address, and so on.
Exactly.
And what about schema? What role does that play?
So the schema is like the blueprint for your database. It defines the structure of each table, the data types for each column, and the relationships between tables.
Okay, so it's like the architect's plan for the database.
Precisely. It ensures that the data is stored consistently and that the database is organized in a way that makes sense.
Got it. Now let's talk about primary keys. I remember this being mentioned as a way to uniquely identify each record in a table.
Right. So think of a primary key as a unique identifier for each row in a table. It's like a social security number for your data.
Okay.
It ensures that each record can be easily identified and distinguished from other records.
So you're saying that each customer in our customer table would have a unique primary key that sets them apart from all the other customers.
Exactly. And this primary key is crucial for establishing relationships between tables.
Ah, yes, relationships. Can you elaborate on what those are and why they're so important?
Relationships are the connections between tables that allow us to model real-world entities and their interactions.
Okay.
So, for instance, in our online store example, you might have a customers table and an orders table.
Yeah.
A relationship between these tables would link each order to a specific customer, allowing us to see who placed which order.
So it's like connecting the dots between different pieces of information within the database.
Exactly. Relationships are essential for creating a comprehensive and meaningful representation of the data.
Got it. Now, the presentation also dives into some key concepts that seem pretty crucial for effective database management. Let's start with normalization.
Okay, so normalization is all about organizing data in a way that minimizes redundancy and avoids potential inconsistencies.
Okay, could you give us an example of that?
Sure, let's say you're storing customer addresses. Instead of repeating the city and state for every order they place, you would create a separate addresses table and link it to both the customers and orders tables.
Okay, so it's like streamlining the data structure to avoid unnecessary repetition.
Exactly. And this not only saves space, but also helps maintain data integrity.
Makes sense. What about transaction management? Why is this concept so important for database reliability?
Transaction management is all about ensuring that database operations are completed reliably and consistently. Think of it like this. You're transferring money between two bank accounts.
Okay.
If the transaction fails halfway through, you could end up with an inaccurate balance, leading to all sorts of problems. Transaction management ensures that either the entire transaction succeeds or it fails completely.
So it's like an all-or-nothing approach to prevent data corruption.
Exactly. It's a critical mechanism for maintaining the integrity and consistency of the database.
Got it. And finally, let's talk about security. The presentation touches on this briefly, but it's obviously a huge concern in today's world.
Absolutely. Protecting sensitive data stored in databases is paramount. Data breaches can have devastating consequences for individuals and companies alike.
No doubt. What are some of the key things to consider when it comes to database security?
Well, it starts with understanding potential vulnerabilities and implementing appropriate security measures.
Okay.
This includes things like access control, encryption, and regular security audits. It's also crucial to stay informed about emerging threats and best practices.
So it's an ongoing process, really.
Exactly. Database security is not a one-time fix. It requires constant vigilance and adaptation.
Right. Well, we've covered a lot of ground today. We've explored the two main types of databases, delved into the world of SQL, and even tackled some pretty complex concepts like normalization and transaction management.
Mm,
I have to say, I feel like I have a much better understanding of how databases work and why they're so crucial.
me too.
But the world of databases is vast, and it's constantly evolving. There's always more to learn and explore.